On today's episode of MotoCheez.
So check this out, boys. This is a big portable power station. Right, and it's heavy. Huge 465,000 milliamp battery. 3.2 to 46.5 amp hour, 32 volt, 1488 watt hour.
21 gigawatts!
Lots of inputs and outputs. Let's unbox this. I can't wait to see it. I think you pronounce it OUPES. It has a 24 volt, 8.33 amp, 199.92 watt hour, 115 volt charger. Good size DC charger for 12 volt socket. We'll see how many watts that'll put out. It's got a pretty good size cord on it. Oh, someone forgot to put the reinforcement under the handle. It was in the bottom of the box. That ought to do it. Wow, she's a beauty. %61 battery in it right now. 110 to 120 volt, 1800 watt pure sine wave outlets. Oh, you hear that fan? 12 volt socket, 10 amps, two other 12 volt outputs, USB-C 60 watt, USB-C 18 watt, two QC 3.0 USB-A's. Wow, this thing is massive. LED, 2 levels, SOS. And off. Let's get this charged up. Geez, I don't even know what I'm going to do for a load test. It's got 2 power inputs. Let's let it charge up. So it looks like it's charging at 186 watts. And it's bouncing around a little bit. Here's the OUPES warranty card. Their portable power stations have a 2-year warranty. Their solar panels have a 1-year warranty. And their adapters and cables have a 2-year warranty. That's pretty good. 187 watts. So that little spinny icon right there means the cooling fan is on. So it must be on very... Oh yeah, I feel it. Slowly. Probably to keep the batteries and whatever charging circuits that are in it cool. Has high temperature protection, which would be right to the left of that fan icon. Low temperature protection would be to the right of that fan icon. And the rest of it's pretty self-explanatory. Car, DC, USB-A, USB-C, and AC output. On a car charger with the 7909 transfer cables, it will take at least 15 hours to fully charge. AC charging will take about 4 hours to fully charge. Solar panel input, so it looks like you can connect 4 100 watt solar panels and it would take at least 3.5 hours to fully charge. So it tells you what the runtime is for some items. Frequency switching, so you could change the frequency if you want 50 Hertz European or 60 Hertz American. So it's got a 1488 watt hour. 1488 watts? 1488 watts? 465,000 milliamp hour. 46.5 amp hour, 32 volt. And it's got the LiFePO4 battery, which is awesome. So you have over 1,000 charge cycles. And it's safer. It tells you your warnings, and then it's written in Chinese also. Very nice. Oh, this plug doesn't fit very well. since you can charge up to 400 watts. Let's plug in a 12 volt. That's got a nice stiff feel to it.
That's what she said.
That's what she said. So we're charging 187 watts. Let's see what we do now. It must be sensing what's going on here. Let's try just DC. Maybe I don't have enough voltage because the van isn't running. I could try starting a van. That's what it was. So it looks like we're doing 81 watts with the 12 volt outlet. So now let's see. Plug both of these in. I have a small battery under here with a battery isolator connected. There we go, 269, 270 watts. Don't worry, I got my fan on and my door is open. I just heard my isolator click off, so we'll let it charge through the AC adapter only. I'll come back when it's fully charged and we'll do a full series of tests, including how the sine wave looks. Since I did this on an earlier unit, let's see what the temperature is on this. 130 degrees. About 130 degrees. It's about normal. When it gets over that, it starts feeling really hot. We're up to 68%. It's got a big battery. It's going to take a little while. So we have 112, 113 volt RMS output, 59.80, close to 60 hertz, and a nice clean sine wave right there. 12.65 volt output on the DC socket. We're at 100% charge. And typically, I'll use these two fans, which equal 400 watts roughly. But the battery in this is so big, I don't know how long it's going to take. I guess we'll plug it in and try. See what happens. So we'll start with the biggest fan. $260 watts. Well, 9 hours, 6 hours. We'll plug in the other fan. Actually, we'll start the other fan first to give it a good surge. This is the smaller fan. And then we'll put the big fan, so it'll give it a good surge, definitely over 500. Whoop whoop, almost. So now we're at 421 watts between the two of these, and it's saying 4 hours. So we're at 417 watts. It says it's going to last 3 hours. Time is 9:27, so we'll leave this running, check on it about every hour maybe. And this has a 1488 watt hour battery. Should get about 3 hours out of this. Now it's showing here appliances and what the run time is. Would probably be good tests on a house refrigerator, so I'll probably throw that in at the end of these tests. I'm just doing this test because this is the test that I run on all the units that I get. Yeah, so these fans are literally nothing for this unit. 11:27, 2 hours running. We're at 45%, and it says 1 hour left, about 400 watts draw. 12 o'clock, so what's that, 2.5 hours? It says it's got 59 minutes left and 29% battery. 12:17, and it's still going. It says 42 minutes remaining, 21% battery, and still hovering around 400 watts. 12:30, says 29 minutes remaining, 14% battery. 12:39, 18 minutes remaining, 9% battery remaining. Dropping a little faster now. 12:41, it's at 5%, 4%, 9 minutes to go. See if it holds out. A lot of these kick off at 4%, 3%. 12:42, 3%, still going. Just turned 12:43, 2%, 1%, still says 12:43. I've seen these go all the way to 0% and run. It usually takes one full discharge cycle to calibrate. 0%, still running, 12:44. Says 0 minutes at 0% at 12:44 still. Still going, 12:45. 12:46 and still going. And it's off. And we got a time of 12:46. Pretty impressive. Let's get this charged. We're going to do a time charged. I didn't mention this earlier, but I did show this socket is very loose. Like you just maybe put a little tape around that or something to make it a little tighter.
That's what she said.
So we're going to plug this in. It's now 12:47. Let's see what that E002 stands for. E002 is battery low voltage protection. So I'll turn the AC off and we'll let this charge up. See how long it takes from a 0% charge to a full charge. It is now 1:52, so a little bit over an hour, and we're at 14%. Charging at 186, 187 watts. 2:48, a little over 2 hours, and we're at 25%. 3:49 at 38%. That's a big battery to charge. 4:52, and we're at 50% charge. 5:54, 63%. 8:04, 89%. 8:50, 100%. So as requested by you guys, I'm going to be testing it on this refrigerator. I'm going to plug it in and see how many hours it says it'll last. To simulate a power failure, portable power supply is going to supply the power to this refrigerator. It's a GE refrigerator. It says it draws 11.2 amps at 120 volts. That's 1344 watts. The good thing is the refrigerators don't run 24/7. When they pull themselves down to temperature, they shut off. So let's plug it in. It's not calling for power because it's up to temperature. Lights are on. 102 watts, just a light bulb. Once that compressor kicks on, we'll definitely get some power usage. Let's open the freezer side. See if we can get it to kick on. Keep the fridge open. Ice machine. Well, compressor's finally kicking on. Geez, that took about a half an hour. With the compressor running, it looks like between 7 and 8 hours it's going to work. So we'll keep this plugged in for most of the day and keep checking on it. So this is just with the compressor running. How long the compressor runs, of course, depends on how good the insulation of the refrigerator is. And there's also other factors that draw on a refrigerator, like there's a defrost mode, there's an electric element that goes around the refrigerator, then you have your ice maker and your ice machine, your lights. So we only have 3 of us in the house. Normal usage, I assume the door must open about 20 times a day, maybe more depending on how many are in the family. But this will give us a rough idea how long it'll hold, at least with this refrigerator. Forgot to say when I started this test, it's 8:34 now. I started the test about 8 o'clock. The compressor only kicked on about 4 minutes ago. So it's 926, still drawing 126 watts, which is pretty minimal. I'm surprised it's not drawing more, considering what it says their refrigerator unit will draw full load. We'll keep you updated. It's 10:47. The compressor shut off about 20 minutes ago. It's saying 65 hours because it's not being used, of course. It's now 1:16. Refrigerator cycled off and on a few times. Of course it's off now, but wow, looks like it's going to last a long time. It is 2:20. Refrigerator's on again for a little while. 59%. Holds up pretty good. Well, judging by this storm, that portable power unit might be doing its thing, because we're probably going to lose power like we always do. Need the rain, but not this bad. 7:30, and this thing's still going. Well, it's just about 9 o'clock, so I'm going to plug it in the wall and continue this test tomorrow morning.
The next day.
It's the next morning, and I was going to plug this in, but there's really no need. We'll just calculate how long it was going to last. Right, Kitty? Hook my 100-watt solar panel up. See how many watts it'll do. Pretty good. Nice clear sky. Wow, I hit 70. That's a first on that solar panel. I think the best I've ever done was about 65. We'll let it charge up on the sun for a little bit. It is 12:15.
A few moments later.
Sun's in and out, but looks like AC power and DC power can be used while it's charging. It's now 12:29. So it hasn't been that long, but it did come up a few percents. It's cloudy now. The sun is cranking pretty good now. We're up to 18%. The time is 1:45. I think that's enough solar charging for today. It works. Of course, if you had 400 watts of solar panel, this thing would be really kicking. We're on the workbench charging with supplied power supply. I'm going to see what this does for fast charging in these two ports and also that port. It says fast charging, 13 watts on that port. Those ports are tight. Fast charging, 13 watts on that port. 10 watt USB-C. Says fast charging. That one's doing 14 watts. And we'll try the 60 watt. That one also says, oh, that says super fast charging. And that's doing 18 watts. The Samsung S22 Ultra. So those are working properly. 25 minutes until full on a super fast charge. So what do I think about this unit? It's definitely a powerhouse with the size of the battery that's in there. The supply charger does a pretty good job at 187 watts. Go up to almost 200 watts, although I have not seen it. You want a portable unit. This is probably the largest they make that's portable. They do make one that's a little bit larger than this. I can actually see a unit of this size running like a small cabin. If you want to get off the grid and get yourself like 400 watt panels for the roof, I think this thing would last quite a while. Something that you could take up with you and leave and take it with you, so you don't have to have it permanently mounted, because 1800 watts with a 4000 watt surge is pretty massive. I gotta get myself some more solar panels, at least 400 watts worth. I'd like to get about 1000 watts to 2000 watts for my house. This would be a heck of a bug out unit too. If something goes wrong, you got quite a bit of power. As long as you keep a solar panel with you, you know, just to be prepared. So I'm going to put some links down below with a discount code, and if you're looking for something that'll run pretty much everything that you need in case of a power outage, or if you're going camping, this might be the unit for you. Thanks for watching.
Hey, don't forget to like, comment, and subscribe. We'd love to hear what you have to say. Hit that bell if you want new notifications on new videos. Links for products used are in the description and on MotoCheez.com. Thanks for watching.